Everyone.
Good luck.
Excellent, and welcome to everyone. It's 12 o'clock and we'll start this fourth Simplex Connect event. I'd like to welcome everybody to who's joined us today, and I'm sure you're going to have a very interesting session of talking about how we can help to cut cloud costs about 50% with no downtime. So that sounds like a really good proposition, and I'm sure you'll be really interested in this. Today, I'd just like to sort of do some of the housekeeping stuff first, as we normally do. We just need to tell you that obviously the session is being broadcast live. We are recording the session, and there will be opportunities for questions both during and at the end of the discussion. And we're also this time we're introducing some polls for you to actually interact with. So hopefully you'll get some feedback as we go along, which will help also with the panel to discuss, you know, what we're talking about and help shape the conversation for you. So with that, I'm going to sort of introduce the panel to you. And today we've got four really expert guests who have got loads of experience in this, and I'm really looking forward to having a chat with them. We're joined particularly today with a focus for the chaps and the guys from CAST.AI. And what I'd like to do is just introduce the team now. I'm going to start with Justas, if you'd like to introduce yourself, please.
Sure, of course. Yeah, so my name is Justas Petronis. I'm a senior product marketing manager at CAST.AI, and basically my job is to help explain the difficult concepts that lie behind multi-cloud.
Excellent, and thank you for that. And also today we're joined by Laurent Gilles, who is the CTO for CAST.AI, and thank you very much for joining us, Laurent.
Thank you very much. Good morning, guys. So my name is Laurent, I'm one of the founders. Super excited to be here.
Excellent, thank you very much indeed. And as we've done before, we've brought in two expert panelists who have a different dimension, if you like, to the actual product side. Firstly, I'm going to introduce Omkar Pathak.
Thank you, Paul. Good afternoon, good morning to everyone. My name is Omkar Pathak, and I head the digital transformation team for ecosystem and platform business working at Konica Minolta. And I'm primarily responsible for delivering the technology strategy for the new business initiatives in Konica Minolta. So that's how I'm connected to this. Thank you.
Brilliant, and thanks again for joining us, Omkar. As I say, it sounds like a really challenging role for you, and hopefully you'll get some use out of this as well.
Certainly, thank you.
Finally, I'd like to introduce Satish. Satish has joined us this morning from Prodapt.
Thank you, Paul. This is Satish Billakota. I head the cloud practice in Prodapt Solutions. We are a services company very much focused on the telco industry and media. As part of my role, I drive strategy for our customers on the cloud transformations. In that respect, these days, the multi-cloud is the norm, and some of the challenges that cut across IT workloads, the network workloads, and some of the customer workloads across this, 3 or 4 hyperscalers that we're talking about, including on-prem, etc., is a specialty that I'm currently working on. So that's what
Excellent. Yeah. Thank you very much indeed, Satish, for that. So moving on, as I say, we have the subject today really on cloud, and I'm sure, as we will find out, most of us either are using cloud or should be probably considering using cloud. But obviously, the concept of multi-cloud and how you might manage that is a bigger question. And I wanted to sort of kick this off with perhaps asking Justas here, just what you see and what you think the key challenges are for businesses with regards to how they choose and how they use cloud services, and importantly, what is CAST.AI doing to help that?
Sure, that's a fantastic question, and honestly, I'll take my while to answer this question. So if it's fine, I'll just share my screen and I'll show you something. So to answer that, we have to go through basically 3 acts as if this is a story. And at the very end, Laurent will be like a dessert, in essence, showcasing actually how this works. So I just want to jump in and say that, of course, we know that multi-cloud is possible, but I want to show you something, just a tad hint, and we'll come back to this. This is an online boutique shop. We took this from Google. It's an open source code. It's actually running at demo.CAST.AI.co. And what you can see here is actually an online e-shop that, if you pay some attention here at the top left corner, it says that it's running on Google Cloud. And once I refresh the page, it switches to AWS. I refresh it again, switches to Google Cloud back, right? I can find an item, I can add it to cart, it switches to Google Cloud, so we have consistent persistency here, right? And I can just keep browsing around the site and it automatically switches to the specific cloud provider that at that given point in time actually makes the most sense. Well, naturally, the question is, why would you want to set it up in this way, right? And that's basically the answer. So honestly speaking, it requires some just a small amounts of historical explanation. So first of all, it used to be that, well, enterprises, they wanted to develop proprietary solutions, but they had to rely on on-prem infrastructure. It made total sense because it provided complete control on resource management. However, companies had to develop every single piece of the puzzle by themselves, right? And they had to plan those resources months in advance. And that required developers to actually remain within those resource limits, within those constraints. However, startups, they started pressuring these enterprises, right? Because they were always constantly flexible and fast. So to sum up, this first good old days, Act 1 basically meant that enterprises had complete control in infrastructure, but they always had to maintain it by themselves, and they lacked flexibility. So this is where the cloud trap happened, honestly speaking. Why? Because enterprises decided to migrate to public clouds like AWS, Azure, Google Cloud, and they immediately gained speed and actually eliminated all those on-prem costs that they used to have. And this allowed them to have access to global computing resources at their fingertips at any given point in time. And they were able to actually rely on certain reusable cloud products, tools. And this naturally, this was amazing. This was a windfall because this migration to cloud allowed enterprises to focus on the most important puzzle pieces that they had to develop themselves. The problem is that they got locked in and they lost control. And I think this pretty much happens with every single company that shifts to public cloud. Why? Because they had to rely on those cloud resources and products. And at the end of the day, they got on the hook basically for those compounding cloud computing costs, which I think every enterprise can agree that they are exorbitant in a lot of cases. So this means that if it was so cool and awesome when you had to complete control on your infrastructure, but you weren't as flexible, you aimed to get that flexibility, migrated to the cloud, removed all those on-prem costs, you didn't have to maintain your infrastructure yourself, but that increased those cloud computing costs. We believe that there's an Act 3 actually, and enterprises, they can stay fast and flexible, have that complete access to global computing power, rely on those reusable cloud products, and given the fact that they long for that control that they used to have on infrastructure costs, well, there's an happy ending here. And what they need, we see in the industry, they need that speed and flexibility. They need global computing power. They need those reusable products. They need to have control on costs. And it's pretty simple. For speed and flexibility, you need something that would be akin to no ops, or what we call AI ops, infrastructure management. We don't need operational teams constantly working on the infrastructure. More so, my apologies, something wrong with the slides. Also, they need to have that complete access to public cloud providers at once, all of them at the same time, right? The problem is what happens when one of those providers goes down, right? And we saw that with AWS last year, at the very end of last year. And unfortunately, that affected even COVID-19 registration and testing systems, which was super unfortunate. So we believe that you can have all of those if you stretch your solution across multi-cloud. So we believe that what enterprises actually need is some sort of a NoOps or AI Ops multi-cloud infrastructure management platform. And this is where, of course, we see the benefit that we can bring. How the story actually can change, to answer that question finally. Well, if you choose this type of a multi-cloud platform, you gain resilience and automated failover strategy. You automate your infrastructure provisioning. At the end of the day, you can reduce your cloud computing costs. And this is multi-cloud the way it should be, honestly speaking. It's a data multi-cloud, it's a service multi-cloud, and it's a workload multi-cloud, right? Why? Because we believe that being locked in with a single vendor is complete evil. And this is possible because we basically cluster AWS, Google, Azure, DigitalOcean we've just added in a single cluster, in a single region. And these data centers are not further than 5 milliseconds away from each other. This is why it's so significant. And I think just to explain this and to show you how easy this actually is, Laurent, I think you can take over basically here.
What I'm going to suggest first, guys, that's really interesting. And I say, it sounds like the perfect answer. This demo, I'm really looking forward to. But what I wanted to do is just interject there. I think we have a poll and we want to just do a poll very quickly. You've just heard about the value of cloud. And Deb, if you can put the poll up, we were going to ask the audience here today whether I'll ask you the question of how many cloud providers do you currently use? Are any of you using sort of multi-cloud, maybe independently, but or do you rely just on one provider? We'll give you a couple of seconds to put a result through, and then when we're ready, we can just see the answer for that. Hopefully that first introduction from Justas will does definitely whet the appetite for, as you say, some of the key things that the benefits that you can get from scalability and resilience and everything else. And it looks impressive. So how are we doing? Have we got a good response yet? Let's have a look. We normally get the thing up on the top there. There we go. Look, so that's there's a good result there. That we've got a not quite a majority, but 50% of you are using more than 3 cloud providers at the moment. So that's really good. And as I say, everybody looks like they're using something. So we're obviously in the right place and using these services. So with that, I'd like to move on again. Sorry, Laurent, but to interject there. But I'd like to move on to yourself now. If you can perhaps give us a little bit more of a demonstration of what's going on. So over to you.
Thank you, guys. Can you guys see my screen? Okay.
We can.
Excellent. And a very interesting poll. 83% use more than one cloud provider. If you add 2 clouds plus 3 clouds, so very interesting results indeed. We see a lot of this in the marketplace. So I'm going to show you a little bit of what was behind the demo or the quick demo that Justas did. So this is the online application that we have deployed. This application has been deployed across 3 different cloud providers. Now it's one application. It's not 3 deployment of the same application duplicated 3 times. It is one application. This application is using 3 different VMs, 3 different machines. It just happened that one VM is sitting inside AWS, another one is sitting inside Google, and another VM is sitting inside inside Azure. And as Justas say here, we're streaming the entry point of what is the cloud provider that is currently rendering this page. And so what is very interesting with this is by the way, a very simple e-commerce app. It's an open source e-commerce app. It was designed by Google. We have not changed a line of code on this application. This is the exact thing that was deployed or open source by Google. We just happened to deploy this application on a Kubernetes cluster Kubernetes cluster means on a set of machines that are run by Kubernetes, which is one of the most accepted standard for cloud native application. So this application has not been changed. There is no line of code change to this. The only thing we do here is we are showing to you here for the demo, we're showing to you here what is the cloud provider that is streaming this application. So it's an e-commerce app. Let's say that I like this typewriter. I'm going to click on it and say, well, great, I want to add this into the cart. So notice now that the one of the 3 VM that is streaming this page, or the entry point of this application into my cloud infrastructure, is Azure. So I add to cart. So now I have one item in the shopping cart. Notice that the shopping cart now is streamed out of AWS. I go back to the home page by clicking on the logo. Now I am on Azure. Let's say I want to buy this camera lens. Now I am on Google Cloud. I add to the cart. Now I am on Azure. If I click on the shopping cart itself, or if I refresh it, then now I am on Google Cloud. You can see that despite the fact that the entry point of the streaming of this application is different, the shopping cart is always the same. So the data is completely transparent. In fact, the entirety of this application is very, very transparent. This application do not care much where it runs. The point is it runs on 3 different places, completely transparently for the end user. Let me go and show you a little bit more of what is under the hood. So this is the cluster here. Let me show you from the beginning. This is the cluster where this application is running. A cluster is a little bit of a technical term. It just means it's the group of machine. It's the Kubernetes word. It's a group of machine where this is running. It's running on these 3 cloud providers, as I mentioned before, and it's running on these 4 machines. So the first machine is what we call a master node. This is a Kubernetes master. This is just the control tower that is handling it. And then we have these 3 VMs here, one on AWS, one on Google Cloud, and one on Azure, that consist in the totality of the resources that this application is using. I'm going to show you something. I'm going to show you how easy it is to create a cluster, and then I'll go into a little bit more deeper into what is behind the hood. So imagine I'm a developer and I want to create this application. I want to deploy this application. It's very, very simple. I click on create a cluster. I put my cluster name here. Let's say this is the name I'm selecting, number 99. I want to run this into a location. I can be in Frankfurt, or in the US East, US West, or South America. We actually have 84 of these. I'm only displaying 3 of them. But imagine that I want to deploy this in US East. I select the size of the cluster, small, medium, basic. Doesn't really matter which one you select, because CAST will deploy across the location you select here, and CAST will actually decide for you how many machines you really need for this application automatically. So I say, great, I want to deploy this on DigitalOcean and on AWS. Here I just put my cloud keys. So I'm installing this inside my cloud accounts of this 3 cloud provider. And then I'm connecting this 3 cloud provider over a VPN. Nothing weird, nothing special. I click on create a cluster, and you will see inside a few minutes, we are not going to wait for it, but you'll see inside a few minutes that I will have created an environment, an infrastructure across 2 cloud providers in 5 minutes. And it's an infrastructure that is completely resilient to disaster, to a cloud failure. But remember that because this application live in all these places, Amazon, Google Cloud, and Azure, if Amazon goes down, it doesn't really matter, because we have the other 2 places anyway. And Kubernetes is made in a way that whenever there is a node that is missing, so imagine that if you take the nodes that I had before, I had 3 nodes of VMs. It's the same concept. I have these 3 machines here. If I destroy or if I delete one of them, it doesn't really matter, because I have the other 2. And therefore, the system will autonomously or automatically adapt, change itself, reconfigure itself, and say, oh, I'm missing 1 machine. No worry, I'm going to create a new one. Because you saw the shopping cart here was completely independent for where it runs, it means that if data is distributed, if the AWS goes down, my shopping cart will still show that I have 5 items into it. You see, what I just show you in a few minutes must be one of the most resilient e-commerce platform in the planet. It runs into 3 different places. It runs completely autonomously, meaning one place disappear, doesn't really matter, there is the other 2. Kubernetes and CAST being the control tower will immediately add the resources that are missing. That's the beauty of Kubernetes. And because we are able to stretch this cluster over these 3 places, we also have a lot of what we call right sizing elements. Missing a VM is the obvious one. That's a cloud failure. But the another example just as well is you can notice here that my memory is quite heavily used. That's not a problem. If I reach more than 90%, then I will automatically create a new worker node. The system will select where to create it within AWS, Google, and Azure. The system will say, well, you know what? The 4-core machine is actually cheaper on Google. So if one of my machines is being used too much, that's a problem. I will just duplicate it. I will find the best place within all the cloud providers that are selected, the best place in the sense that what is the most price efficient cost of $1 per compute quantity or per memory quantity. The system will add the node automatically, the same way as the system will delete the node automatically if I don't need that machine anymore. So it has this built-in resiliency. It has a built-in right sizing. The right sizing, so meaning the addition of resource or the destruction of resource, will be made according to the most efficient place at the time it's required. It's required to add that resource in a fully automated fashion. So that's a very quick, very easy, very simple demo on what this kind of multi-cloud product can do. We're super excited to present that to you guys, and we'll look forward to hear your questions when you have them. Thank you. Back to you guys.
Thank you very much indeed, Laurent, for that. Very, very interesting. And we've got a couple of questions that have popped up already. I think I will ask the first one. I think if we've got anyone who wants to actually come in and actually ask a question, Deb will be able to sort of bring them in.
Yeah. So one of the question, Paul, maybe let's do that. One of the question which is prompted by Manmeet, maybe we'll get Manmeet to come on the line and ask the question. Is that allowed now, Paul?
Yeah, that's okay. Fine. Yeah, that'd be good.
Let me do that. Let me get Manmeet to ask that question. Just give me a second.
I expect there's lots of questions. I've certainly got lots as well, but let's get the first one.
Me too. Being a panelist, I too have a lot of questions, and how I can see it already helping me.
Take it easy.
Manmeet, if you can hear us, you can ask your question now.
Yeah, am I audible?
Yeah.
Yes, you are.
Okay, thanks, Dave. And first of all, very interesting, scenario of what we have just seen. Definitely, opens up eyes how things are moving from one cloud provider to another, that too seamlessly. But I have a question, and I can see a couple of other questions which are also, going towards the same direction. So all that's good from a redundancy standpoint, from the first or the front end standpoint. But how about how are we managing the volumes, the tiers, the snapshots? Are we saying that we are incurring cost from a storage standpoint and other resources standpoint in all the cloud providers? Or is it happening at one? Okay. And then if that's the case, then where when we are talking about this movement from one cloud to another, aren't we having dependency on one cloud only in that scenario?
That's a very good question indeed. I guess I'm gonna answer it. So there's 2 options that developers have. The first option is if your primary concern is resiliency to a disaster, meaning if what happens if one cloud goes down, most of the time the cloud doesn't go down, but there are many micro failures. Let's say what happened is one VM goes down or one particular service go down in my cloud provider. Is this going to affect my application? The data is the most important here. So imagine this: if the system select automatically, let's say Azure in this case, to store the data, and Azure goes down, then effectively, even if the workload is on the other 2 clouds, it doesn't really matter. The data is not available anymore. So what we advise developers is to be smart about how they distribute the data. And the example I gave you just now is actually using a SQL database, a very, very innovative SQL database from our friends at Gigabyte DB, where we are actually duplicating the data 3 times on the 3 cloud providers. And this is done on purpose because the reason why we're doing this application is for the disaster recovery angle, so the data has to be replicated. I'll show you how it works because it's actually very simple. So this is the Gigabyte open source dashboard, and you can see here the Gigabyte has 3 different pods where it runs. One is what we call the leader, meaning one is the current source of truth for the application itself. And we have 2 followers. The followers are the slaves, so they are the copy of the leader. Gigabyte is handling all this copy master follower automatically. And right now, the leader is a pod, so it's a workload that is called Yebi master-2, and it runs inside AWS. The other 2 followers, one is on Google and one is on AWS. And just to show you that it does work and is completely resilient, if I delete by mistake, or if there is a micro failure and this master-2 is deleted, I'll do that very quickly. This is my pod. This is the process that runs the database, the current master of the database. And if I click on delete here, that's obviously simulating a micro failure. So now this pod has disappeared. Gigabyte is going to tell me, hey, I'm missing one. I'm going to switch to another place. Sorry, I clicked the wrong. And if I go back to my application, so now I simulated a catastrophic micro failure where my database has disappeared. I just refresh this. I go back to the homepage. Look at my shopping cart. It still says 5. If I click on the shopping cart, I still have the items that I was buying. The database is suffering a catastrophic failure. The master has disappeared. The data is still here because the data is distributed over these 3 places. There is extra cost to duplicate the data. Of course, you have to duplicate it 3 times, but the purpose of this is disaster recovery or resiliency to disaster recovery to a disaster. Then we are smart about it. You notice that applications still run. The database is down. The master database is down. The system just said, fine, I have another 2 places where it can run, and I'm going to run it. And just to show you that it's really down, if I refresh this, you can see the Gigabyte saying I'm missing my place, and the leader is now a different entity that happens to live inside Google. Did I answer your question?
Yeah, sure. Thanks for that. So basically what I take is that, instead of building resiliency in one cloud provider, rather it's a good choice to build it elsewhere, because anyways you're paying for that resilient workloads. So that's the take which I take. Just another follow-up question, that what are the use cases / applications or scenarios you feel are the best suited for this kind of application?
Yeah, that's also a very good question. I would say all the mission critical applications, and typically what we see in the marketplace, a lot of SaaS companies, a lot of software as a service companies are using CAST for that purpose. Any SaaS company is using their services as a primary tool, primary product that they sell, and for them, having their product down is a catastrophe for their business. I mean, think about Slack that was down 2 weeks ago just because some machines on Amazon went down, and it was just a network problem. And if Slack was living inside multiple places, they would never have been down. And for them, that was millions of dollars. So any mission critical, any SaaS, any company that use the internet as their primary means to deliver a product is a great candidate for this kind of solution.
Sure, thank you.
Excellent. Thank you very much for those questions. And as you say, very, very interesting and very informative. What I'm going to do actually is just ask, we've got a second poll, which I think links into some of the questions that were asked there, because I think, as you say, any questions that you put in, by the way, I should say, we will answer afterwards if we don't get a chance to do this today. So don't be put off by time or whatever else. If you've got a question, please do answer it. We're really keen to get that, and we will respond to you. But one of the things there was the questions were sort of probably predictably sort of looking at cost and resources and things like that, and what's this going to do to my IT budget. And the second poll that we had was actually very much related to the same thing, and I wanted to ask the audience whether your IT spend had changed after adopting cloud services, and whether it's increased, decreased, or there's been no change at all. Or if you don't know, you don't know. But yeah, just seeing where you see your costs as part of adopting cloud going forward. So we'll give you a few seconds to sort of do a quick one. These are meant to be quick, so hopefully you're not getting your calculators out and things, but we'll just sort of see how it goes. I was also interested, Laurent, in, as you said, I think you demonstrated it, things like your, if you've got your master for the clusters in one particular cloud environment, if that cloud environment goes, you've obviously got an automatic failover, so a new master creates in another cloud. So you're covering, I mean, as you say, very much the resilience, disaster recovery type scenarios there. So that's good, yeah.
Thank you.
So let's have a look and see how we're going there. So yeah, so interestingly, IT spend, the view is that it has increased, as I say, and as I say, some of it, in some cases we've got decreased there as well. So it is actually quite a broad mix, which is probably what you'd expect depending on what you're doing and the reasons that you've had to deploy to cloud in the first place. What I'll do is I'm going to bring Omkar in, if that's okay. Hi, Omkar, and I wanted to sort of perhaps follow up with you in terms of maybe as a sort of a leadership, and in a leadership role of transformation for Konica Minolta. I mean, you must have loads of challenges around how you can use cloud, or how cloud is used across the organization. You've got a global organization. Challenges that you're picking up on, about how to get the best out of cloud services across the group.
Thanks, Paul. So yes, I mean, first of all, thanks, Lauren. It was a very, very good demo, and I can already see some of the benefits that we can adopt at Konica Minolta. So Konica Minolta is a very interesting example because we are a very federated organization. It's a global organization, but absolutely segregated and federated. So we have got it's a multi-cloud environment that we currently have, but our multi-cloud environment is spanned across different regions. So we have got AWS in the States, we have got Azure focus in Europe, and we have got Alibaba in APAC. Yeah, and even within Europe, we have got 28 countries, and some of those countries have got their own cloud adoption. Yeah, so looking at the product that you have just demoed, I can clearly see massive benefit when my IT is managed centrally. Yeah, because I can have CAST.AI and I can manage all my multi-cloud through a central port and through a central location, yeah, or through a centrally managed organization. However, when I have got cloud which is in different regions, and those regions are responsible for that cloud, so what happens is the provisioning and the management of that cloud, I still have to give it to the regions. So they have to have that autonomy, they have to have that flexibility of managing those clouds. However, as Konica Minolta headquarter, they would like to have a good understanding of the spend that has been done on the cloud. Yeah, because there is a contribution from the headquarters towards management of that cloud. So you have to keep that balance of giving that flexibility to the regional CIOs and the CEOs to manage it. However, as a headquarter, I would still like to understand how much that spend has been, and I would like to keep a tab on that because I would like to have a year-on-year understanding of how my cost is being utilized. If I've articulated my question properly, and the situation that we have, so I can clearly see, and if we are able to do that using CAST.AI, then I would like to have a year-on-year understanding of how my cost is being utilized. If I've articulated my question properly, and the situation that we have, so I can clearly see, and if we are able to do that using CAST.AI, then I would like to have a year-on-year understanding of how my cost is being utilized. there is undoubtedly a lot of potential that we can utilize this in Konica Minolta. That's one aspect of it. The other aspect, as I said, is we are venturing into new business initiatives. We are moving into application and solution business, which would definitely mean that we will have a variety of applications that we are developing for our customers that will be deployed across multiple clouds. And sorry, yeah. So there is.
Losing you a little bit, Omkar.
Am I audible? Yeah. So I think it will be very interesting.
We're just losing you a little bit there. So yeah, if you're still.
I am. Can you hear me?
I think it's from. I think Paul actually.
I think we're good, Paul. I think it's just your band signal is going on and off. So I think carry on, Omkar. We can
sorry.
hear you.
Yeah. So sorry to take a bit too long, but that is how. So I can see a multifold benefits of CAST.AI, not only as an internal organization, but also for the business.
Thank you. Let me address the cost side of things. So the use case I showed you is the idea that I'm deploying one application and don't duplicate the application 3 times. It is one deployment. The application just happened to need 3 machines, and I'm able to use 3 different cloud providers to provide this compute resource. And then I simulated what happened if one of these machines go down, or if one of the workload go down. In this case, it was a catastrophic failure of a database, and showing the resiliency of this. What we really built, if you think about it, is the idea that the infrastructure should be autonomous. The infrastructure should repair itself, should have a self-healing mechanism and detect, oh, something is down. Out of the box, it's okay. I will recreate somewhere else what was down. And if I'm smart with my data, which I showed in this case, I will switch around to another location or to another source of data, so nothing is broken after this. So the idea of autonomous also mean the opposite. If I have a lot of traffic that are hitting my app, then I'm going to do the opposite. I'm going to create new resources to do this, also in a fully automated fashion. Imagine that I need a new 4-core machine, and I have selected these 3 places to play with, AWS, Google, and Azure. Then the question the system is going to answer is, great, I need a new machine because I see requests per second going too much. Where is the most cost-efficient place to add a new 4-core machine? Is that on Google, is that on Azure, or is that on AWS? We have done benchmarks over 500 regions, 500 different machines in 84 regions all over the world. And we know where is the lowest cost 4-core VM available within the 3 cloud providers that I have selected as a developer. So the tool in the autonomous meaning of a Kubernetes cluster that span across multiple locations means I now have multiple locations to select the most cost-efficient resources that I'm going to add for this application. Fully automated. This is a system deciding for itself what new resource I need to add, where is the best to add it. But you have also the opposite, and I'll finish on this for cost. The opposite is, well, right now it's the night, my business is in Europe. Well, at night people sleep, they may not buy a new camera at 3 a.m., although I have done that in the past. But most of the time, your traffic will go down during the night, and then the opposite is going to happen. The machine will say, oh, you know what? I have this 4 machine, but in fact, one is really not very well used. Can I move the workload on this machine to others and destroy that VM? Because it's not necessary anymore. And it's the same idea. We can scale up to add resources. When I say we, it means the engine decide by itself that it should scale up if you need something. It should scale down if you don't need. So you have the guarantee that with this kind of autonomous system, that's just being an example, your cost will always be optimized. You can also say differently. You can say you're always right sizing what you need according to the strict minimum, never less and never more. And then the developer or the DevOps is fully in charge of these policies. So you can say, create a new machine when the CPU is going to over 90% as a guardrail, right? You can also do the opposite. You can say, well, after 40 CPUs, I don't want to do anything anymore, because then my, yes, it will be very fast, but my cost will increase also. So you have this set of policies up and down, so you live within guardrails that you define, and you let the system make these decisions in real time. So that's the part of the cost optimization that is always built in. To finish on your budget question and the head office being in control of what's happening. If you notice, when I created my cloud, my application, I'm actually going to show this because it's a lot easier to show it than talk about it. When I was here and I was creating my cluster, one thing that I was doing is I was selecting the cloud providers that I was going to use. You notice that here I have to select my cloud credentials, and that's where the corporate governance come in. As a developer, I can only create a new environment within the credentials that my employer or my team is allowing me to. So if I select here my credentials inside Google Cloud, it just means that I'm going to install this app inside the cloud account that is owned by my company as a developer, and with all the security and the budget and the follow-up and the management of this cloud account. It doesn't belong to the developer. The developer is only using a key, a credential, but the owner of that key, of that credential, is in this case the central location. Can be a headquarter, can be the head of IT, the CTO. They are the one who control the keys. Yeah. So it's a long explanation for you.
I know, no, and I guess you're getting loads of other questions, so I'll keep my mouth shut for now.
No, thank you for that, Omkar.
Thank you.
Thank you for the response, and I apologise to everybody. I obviously disappeared there for a bit, but hopefully I'm back. Satish, I just wanted to obviously bring you in on this as well, in terms of, from a perspective of an organisation that provides sort of services to others. How are you tackling this challenge, and are you seeing this demand for multi-cloud management?
Thanks, Paul. First of all, I think it is a fabulous product, very exciting, and a great demo, Lauren and you asked, right? And very good question on the business side. I think typically a lot of CIOs and do speak about how the federated ecosystem works and how are you going to manage that, right? I think it is a very valid real life problem that the leaders are dealing with today, right? And I have a couple of comments to make on what we are seeing from an industry standpoint. When I meet our customers across the globe, across telecom and media, most of these are also like the global players, but they have not NatCos and so on and so forth. I think the reality is, 99% of our customers are using multi-cloud, so they do need a system that controls the multi-cloud ecosystem. So I think it is the product that we looked at is pretty into that space of addressing that problem. So absolutely, right? And I wanted to sort of explore 3 areas further in terms of when people are talking about multi-cloud and any cloud transformation to that extent, a lot of that depends on how your applications are going to play, right? A lot of the times, especially in the telcos and media sector, you have coexistence of a very forward-looking microservices applications, but also you have a significant legacy monolithic applications as well that need to move to cloud. Both of them need to move to cloud, right? So in that context, my first query was, how would you actually, what is that application owners or application developers need to do to enable multi-cloud operability, and where does CAST.AI play into it? That is one question. And the second question is, from a proximity standpoint, it's when you have a global operations, most of these people also use some sort of CDN sort of those sort of activity across the globe to distribute traffic across the globe, right? Based on where it is coming from, and a lot of API calls and stuff that you would expect from serverless as well, right? Uh, any thoughts on how would you actually plan using CAST.AI in those scenarios from a technology standpoint? Would be good as well. And the third one is, I think you will have an interesting competition from the cloud providers themselves, right? Because they also see this as a problem. For example, Anthos to that extent is sort of trying to solve the same problem. So I'm just curious to know how you're different from a Google Anthos to that extent. So I know that those are the three things that came into top of my head while doing the demo, right? So.
Cool. So let me answer it. The first question, what kind of application, or does the application need to be special to be deployed in multi-cloud? That's how I would answer it. Understand it. No, the application doesn't have to have any special thing. Remember, what I did is I created, it's a bit technical, but in the world of cloud native application, Kubernetes is the accepted framework, is the accepted orchestration for containers. We create a full open source conform Kubernetes cluster on which you just deploy an app with your favorite CI/CD tool. There is absolutely no change of one line of code for this application to be deployed on a cluster that span across multiple locations. Think of this, these three machines, one on Amazon, one on Google, and one on Azure that I demonstrated, they may as well all be on Amazon, or they may as well all be on Google, or all be on Azure. Doesn't change anything, it's just three machines. We happen to select smartly where these machines are located to ensure resiliency or cost optimization. But this is fully transformed. The application has no idea that it's actually running in three different places. The only thing the application sees is, oh, I have three machines on which I can deploy my things. And Kubernetes orchestration is deciding where to send the workload distributed over these three machines. So we're not duplicating the application three times. It is only one install. This application just happened to use 3 times 4 CPUs distributed into 3 machines, living into 3 different places, but it's fully transparent. This application I show has not changed. We took the one, it's actually the one that Google used for Anthos demonstration. And this is the reason why I did it. We took this one, we haven't changed one line of source code. We just said, let's deploy it on the Kubernetes cluster. We define what the cluster is, we define the definition of the cluster. This is typical for a CI/CD pipeline. And then you just watch the installation. So nothing to do for this one. Use of CDN. Actually, this application use Cloudflare as a CDN. And so it's completely transparent as well. It's just a web app like any other web app. Happened to be deployed on a Kubernetes cluster. This happened to be on 3 different places in US East. There is no other requirement. It's just normal things. Yeah. Behind the hood, we abstract the infrastructure so this application can be deployed in a fully generic way. So that's question number 2. No impact. Now, Sati, I need you to repeat this third question.
The third question, I think, is Anthos, right? So how does it?
Anthos. Oh, yeah, Anthos. I have a lot of respect for my colleagues over there. It's a small world. We know each other very well. Anthos decided to go a different route. And this route is also very valid. It's just different now than ours. And the purpose of Anthos is to give developers the same familiar look and feel of their development environment on Amazon or on Google or on Azure or on-prem. That means that Anthos is able to create silos. So if you want to deploy something only on AWS, you can still use Anthos to do this. Then because the developer have the same look and feel, he knows what Anthos is, you don't need to learn AWS to deploy an application on AWS because you have Anthos as the front end. So Anthos is multiple silos of one cloud Kubernetes management platform. It is not a multi-cloud Kubernetes management platform in the sense of multi-cloud I just told you before. The use case I did is not something you can do with CentOS. You will have, and with CentOS, you select either Amazon, or you select either Google, or you select either Azure, but you can't say deploy in both. Without duplicating it, right? Deploy one thing in both places. This is not a use case that CentOS has. The consequence of this, and I'll finish this super fast, is that CentOS doesn't have cost optimization or right sizing. That's not their thing. Their thing is to simplify deployment in one place, as long as you are okay to do this in one single place. So you don't have a disaster recovery or self-healing the way I described it. You don't have a cost optimization, because that's not what they do. They do something else. So it is a different product in that way. The difference is really in the benefits, in the what you get from it. But there are great things with CentOS. Don't get me wrong. I really like these guys. And by the way, they created Kubernetes in a way. So we all benefit from Google continuing to develop CentOS, and we really like what they do. But their use case has no disaster recovery ideas. Their use case have no cost optimization. They don't have right sizing ideas. That's not what they do. So different tool compared to us.
Laurent and Satish, I'm going to just cut in there a little bit. I'm very conscious of time. One thing that we do try and do on these sessions is, not run right to the wire. We appreciate other people have got probably other commitments at 1 o'clock and want that time. So appreciate it. I mean, this conversation clearly could go on for a lot longer, and I do appreciate the time that everyone's taken. I've got one question I wanted to sort of just pick out. We've got about 3 or 4 other questions that haven't been answered yet, and we will answer all those questions, as I said earlier. But David asked a question around this particular solution with CAST.AI, in that can it manage on-prem resources too?
Oh, well, that's a great question. Stay tuned and come back in a few months. We'll have the answer. Yeah, we're working on this. It's a popular idea. The idea of on-prem is typically on-prem has no elasticity, so it's very hard to add a new machine if you don't have it. It may take a few weeks to add a computer or server. And so the use case we see with customers is they take their application on-prem, they deploy on-prem plus one cloud, and typically nothing happens on that one cloud, but you can offload workload if you have an increased traffic. So they'll offload traffic to, let's say, Google in Frankfurt if their data center is also in Frankfurt. And that's a great use case. We actually do have prototypes on this. So if you guys are interested, I'd be happy to show it to you. And we're a few months away from releasing that. That's a very, very cool use case.
Excellent. Okay, and I'm sure that's something of the thought that maybe David and others may have had on that. As I said, there are many others, but I am going to start wrapping up, and I'm going to wrap up in a way really that sort of thanks all of you on the panel for your time today. I think today has proved to be one of the most interesting and interactive Simplex Connects we've had, certainly online. And I'm sure has brought a lot of questions and a lot of interest from a lot of people. So it does seem, as you say, it tackles a number of the things that we struggle with, out in business, around whether it be managing, a broad, diverse set of resources, or whether we're looking for resilience and disaster recovery in a business critical sort of mission critical sort of system. And I can see, that having this takes a lot of the issues away for, sort of managers and organizations. And as I say, excellent stuff. Thank you very much indeed, Omkar, for your time and your insights from your challenges with Konica Minolta. As I say, I think having that global sort of perspective on things is also an ideal way of highlighting some of the challenges that these sorts of products and this product is particularly addressing. And for Satish, thank you for your time there. And I know you have a number of customers and clients that I'm sure sort of have these sorts of challenges that you are looking to work with. Thanks very much indeed, everybody who's listened and sort of taken part in today. It does show the interest that there is there, and thanks for your participation in the poll. at this point, I think it would be good if we sort of wrap up there, give you time to sort of get on to whatever you're doing next. And thank you very much indeed for your time. And hopefully we'll see you next time. Thanks for now.
Thank you.
Thank you.
Thank you.
Thanks for now.